skip a step or make a mistake or something. Yeah, help yourself. So this one says, describe how to transform the function f of x equals x squared to obtain a graph relative to the function g, and then we got to draw it. So we're doing some stuff here. All right. So we want to try to figure out what this looks like. So nothing up my sleeve. Let me show you what we're going to do. So how does f of x equals x squared normally look? Well, normally you have your x value, your x-axis, and your y-axis. But now that we're fancy pants Algebra 2 students, we're going to say our f of x-axis. And if I come in here, I'm going to say that that is a parabola whose vertex goes through the origin, right? So this would be f of x equals x squared. And now we're going to try to guess, and then we'll use our calculator to verify. We're going to try to guess what g of x looks like. Now, these transformation skills are so helpful on standardized tests. A lot of times, Mr. Adams can look at a function or a graph and then know the transformation and kind of get a pretty good idea of how to graph it. So, first of all, let's rewrite this. This is the same as negative 1/3 times f of x minus 4. Okay. All right. So what does that tell me? Well, that tells me that my a term is equal to negative 1/3. That tells me that my h term is equal to negative 4. So remember, this is a vertical compression. Okay. So that's going to compress it by a factor of 1/3. But plot twist, it's negative. So this is going to reflect about the x-axis. H equals negative 4. Well, that's going to translate four units to the left. To the left, to the left. Everything you own in a box to the left. All right, so let's think about that. So the vertex, so I'm dealing with some stuff here. So I'm going to look at I'm going to, in my mind, I'm thinking to myself, okay, the original parent function looks like this. But the first thing I'm going to do is I'm going to flip it, right? And then I'm going to move it 4 units to the left. So I'm going to go 1, 2, 3, 4. This is going to be the vertex, which is now a maximum. And it's going to compress it. So when we compress it vertically, it's going to expand it a little bit further out. So it's going to be wider, like that. And that's my sketch. How do we verify this? Everybody have a calculator? Let's turn on our calculators and see what we have. Now, before we see what we have, though, we got to think about how this looks. Our g of x, if we plug this in the calculator, will be y2 equals...
Oh, maybe we'll get to go home. Please. Oh, my God.
Okay, hold on. So we have white. The lights flickered a little bit, and the kids think we're shutting down the school. Oh, that's cute. So we're going to say 1/3, negative 1/3 times. Now remember, f of x is x squared. So I'm going to say x plus 4 squared. So that's how I'm going to enter it in the calculator. Is everybody ready? Ready to be shocked and awed? Okay. So we're going to graph the original one, and then we're going to, and I'm going to do it all on one graph. So turn on your calculator. Go to y equals. First one's just going to be x squared. The next one I'm going to put in parentheses. Remember, if you want to enter in a fraction, you can come and hit the math menu and go over to fraction. Choose the first option. I'm going to put 1 over 3, but I just remembered that I got to make that negative, so I'm going to insert that.
Where do you get the fraction?
Hit the math button. Hit the math button here. And then use the menu, the cursor, to go all the way over to fraction. Yeah, and then it's the first option. Yep. I'm going to close my parentheses and then start another set of parentheses, x plus 4, close parentheses, and square that. So I'll leave that up there for a second so you guys can see it. Plug it in the way that I did. Okay. And I'm probably going to switch the colors because I think, didn't I do it backwards? I think my transform function was blue. So I'm going to come over here. I'm going to change that to blue. We'll make it light blue. Okay, okay. And then this top one, I'm going to change to red. All right. I'm going to hit zoom. We're going to do zoom standard, which is 6. Oh, I got something else in there. I think I got a scatter plot. So go to second, stat plot. Choose option number 4 to turn all of them off. And then hit graph. So the red one is my parent function, and then the blue one is the transform function. Notice that the vertex occurs at x equals -4, just like Mr. Adams said. No? All right. Well, it's tough crowd, I guess. All right. You guys are just jealous. Get on my level. Well, we got one more problem to do. All right, you guys are counting down. It kind of hurts my feelings a little bit.
We have lunch after this, so don't feel too bad. Yeah. Just that we have lunch.
All right, there we go. That's what it should officially look like, which is exactly what Mr. Adams sketched. So like I said, what's really helpful about this is if you take the SAT and you kind of have an idea where it should be, you don't necessarily even have to plug it in your calculator. You probably should to make sure, because sometimes you make mistakes. Well, I think we